Today we're going to continue with the conservation of energy topic. In the last video we learnt that energy cannot be created or destroyed, it is just transferred from one store to another. We also looked at the different ways energy is stored and transferred and how we represent energy transfers using diagrams. Today we're going to look at energy efficiency, so what it is, how we calculate it and how we improve the efficiency of our devices. Now in everyday life we use devices which take advantage of energy transfers, but devices will waste energy in some form or another. Let's look at the heater for example. Energy will be transferred to the heater by electrical work. Then the heater will transfer energy to the air around us by a heat transfer. And a small amount of energy will be transferred away as sound. The purpose of the heater is to make us warm, so the heat transfer is useful, good, but we don't need the sound it's creating, so we say this energy is wasted. Now this heater will have an efficiency rating associated with it, and this will tell us how good the heater is at transferring energy as heat. So efficiency is just a number that tells us how good a device is at transferring useful energy. Now if we know how much energy is going into the heater and how much energy is being transferred out of the heater as heat and sound, then we can calculate what this efficiency rating will be. And we can calculate this efficiency rating using the following equation. Efficiency equals the useful energy transferred going out of the device divided by the total energy transferred into the device. So, for example, 100 joules of energy is being transferred to the heater every second. It transfers 95 joules of energy by heat transfer every second, and 5 joules of energy is transferred as sound every second. But quickly, notice that the energy going into the heater equals the energy going out of the heater. Remember, energy is conserved. Some of the energy going out may be wasted, but it's not being destroyed, it's just not useful to us. So back to the example. If we put these numbers into the equation, the useful energy out is 95 joules of energy, the total energy in is 100 joules of energy, so we find that the efficiency is 0.95. Now efficiency does not have a unit, it's not a physical property, it's just a number we have made up to tell us how useful this device is at transferring energy. The number will be given as a decimal number between 0 and 1, or a percentage between 0 and 100%. The higher the number, the more efficient the machine is. Now a device cannot be 100% efficient, it's physically impossible. When energy is wasted to the surroundings, we say that it dissipates, it spreads out. Objects that are hotter than the surroundings will transfer energy to the surroundings by heat transfer. So if a machine has moving parts which come into contact, friction will cause them to heat up. The internal energy of the parts will increase, and then this energy will transfer to the surroundings, so the heat is dissipated. We can reduce the amount of friction by lubricating moving parts. Because this reduces the friction, it reduces how much these moving parts are gaining internal energy, and it reduces the heat dissipated. That means that the efficiency of the device is increasing.